project I've been working on for a while. It's a welder, a stick welder, and it was constructed using two microwave oven transformers, first one and second one here, and I removed the secondary coils, kept the primaries, which are these ones, and rewound the secondaries with 25 turns or so of 10 gauge solid copper wire. Power cords, each transformer has a separate power cord, and of course the cores are grounded. So the primaries are wired in parallel. Of course they have to be in phase, or the peaks and troughs of the two outputs will cancel each other out. So you just have to sort of switch the leads around until that works. And then the secondaries are wired in series, so the voltages add. Then we've got out of this side this pair of lugs that's, screwed down here. There's a cable, a jumper cable, and this is my ground clamp. And on the other side, you go through here, through that coil, back through here, through this coil, and then through this set of lugs here. And this is my my stinger, the electrode holder, if you like. So one end goes to ground, and the other end goes to the electrode. Thus far, I've tested its voltage output. I haven't actually tried welding with it. So one transformer puts out about 23 volts, the other one puts out about 28, and wired properly in phase, it adds to 51 or so volts, which is nice. That should make it fairly easy to start an arc with it. If you have a somewhat lower open circuit voltage, it's harder to actually get the arc to jump the gap. And the way I'm dealing with power control is essentially by routing each of the power cords through a power strip in which is attached a 15 amp circuit breaker. And most of the circuits in my house are 20 amp, so this keeps them safe. Each one is obviously on a separate 20 amp circuit. And so if the welder starts drawing too much current, it goes into whatever thermal runaway or something, then this will just pop off, and the house circuits will be 1/16 inch 6013 welding rods from Harbor Freight. They were nice and cheap, and these also act as a form of amperage control, current control I should say, because they're so thin, and they're steel, and as such they have some resistance, so they will control the current. They'll heat up a little bit obviously, but then you do want the welding rod to be fairly hot. So the first time I tried building this, I actually wound the coils out of 8 gauge copper wire, stranded copper wire, which apart from being a pain to work with, was so thick that I couldn't fit 18 turns comfortably in here and be able to get this I section, the E section, perfectly closed up like that. So what I ended up doing, and this is a little bit silly, is I thought, those magnetic shunts that come out of the transformers, when you take them apart, these things, they look like that. They're sort of layered pieces of metal. They're used as a form of amperage control. I thought, I'll just stack a couple of those inside there and it'll close the gap. And for some reason, it actually drew more current with those things there, and of course it was less efficient, so I was only getting about, 13 volts out of, this was one of the original coils, that was the other one, for 13 and 11. So that wouldn't have given me, nearly enough voltage to actually get an arc started and comfortably maintain it. And of course it was popping those 15 amp circuit breakers So that didn't pan out, and so I rewound the coils, and that ended up being much neater. You know, I got these two sections back together, epoxied them, and clamped them very, very hard in a vise, and they closed up, and now they're all good. And so I set this up, and they're, you know, pretty neat. One thing I made sure to do was I took the ground wire coming out of these microwave oven transformer power cords, and I just sort of screwed it in to one of the holes in the transformer cord. There were a bunch of them, and I just sort of drilled out one and then forced a screw in, and I did the same here with a slightly different hole. And then the whole thing's mounted on a wooden base. This one I used some screws, just sort of drove them in like that on each side around there to sort of keep it in. And this one, the base plate was still attached, so I used that. That was kind of convenient. And then obviously there's just some sort of copper pipe clamps holding these things down so they don't wiggle around, you know, strain relief if you like. Strain relief for these ones is really just the ground wire because that's actually screwed in. So, yeah, oh, and the other thing is this fan, which came out of one of the microwaves, I wired it up, you know, and that should provide some cooling, because what I discovered when, you know, just having it on, I tested it for 2 minutes and thought, you know what, well, maybe I'll run it on a 20% duty cycle. It didn't quite pan out. The coil in this particular transformer, it heated up a fair amount, but the coil in this transformer heated up a great deal more, which is odd because the voltage I get out of this one is about 28 and this one is 23, so you'd think that there would be more current flowing through this coil. But you know what? Maybe this is actually an aluminum coil, and it's not copper inside. It's just got a sort of coppery colored coating, so maybe the resistance is higher. Maybe the core is less efficient somehow. I'm not entirely sure what's going on, but yeah. So there's that. For further plans, I'm hoping later today to test the welder. You know, to actually try welding with it. And I want to try and introduce a choke into the circuit to limit the amperage, because of course, and I still have to do a little bit of research, but a choke, which is essentially is an inductor, acts somewhat like a resistor to an AC circuit. You know, it acts on the circuit in a similar way as just a bog standard resistor acts on DC. And so the idea is that if you put an inductor in series with the secondary coils, it will limit the amperage. And now I'm not entirely sure if this is necessary, but it would be nice just to know that, you know, it hopefully won't heat up these too much. I'll have some way of controlling the amperage. And just for safety, I'll probably be running it on a 10% duty cycle or thereabouts. So there's that. Of course, some math will be necessary to sort of figure out what the inductance of the inductor should be, but you know what, math's not a problem. Math is fun. So let's see if we can get just a sort of wider shot. There's the whole welder, and you know, not on right now, obviously, that's just charging something else. So yeah, there you go.
That's enough.
Hold on. My arc is too long.
We're putting it off.
Okay.
Now that's success.
Off both?
Off both, let me disconnect.